Hello to all. Now today we are going to start the chapter number 2, polynomial. We will start from the definition what polynomial is. So you see that we have already done this chapter in class 9th. Now we are again doing it. So poly means multiple, nomial means terms. So it means the expression in which we have multiple terms. Now we can also think like how polynomial can be defined. This is one of the way of defining. You can have some other ways also, but see, polynomial is an expression means in which constant and variables are used. For example, expression can be 2x plus 3 upon x. So you can see this is an expression in which you can see variable x and some constant 2, 3 and 1 etc. So this is an expression. So polynomial is also a type of expression in which variables and constants are there, but how it is different from expression that this line will tell you. Along with this means all the variables and constant, all variables have exponent as a whole number. See here in expression, this expression is written in the denominator. So if we take it up, then it will be x to the power minus 1. So minus 1 will be like you see, this can be written as 2x plus 3x minus 1. So here x is 1, this is okay, but here x minus 1, which is not a whole number. So it means that this is an expression, but it cannot qualify for being a polynomial. Reason being, in polynomials, all variables, whatever number of variables are used, all must have exponent as a whole number. If they are not whole number, then they cannot be called as polynomial. For example, 1, 2x square plus x, it is a polynomial because here x, the exponent is 2, here exponent is 1. If nothing is written, it means 1. So all exponent of variables, I'm repeating the variable word, please taking care of this, that variables we are talking about, we are not talking about the constant. So if variables have exponent as whole numbers, then we say it is a polynomial. Now take this example, x plus 1 upon x or x plus x is to power minus 1. You can write this as this way also. Here it is x is to power 1. If nothing is written, then 1. Here x is to power minus 1. This is not a polynomial as x has negative, has minus 1 as an exponent, and minus 1 is not a whole number. So please understand this, because one marker question is asked. On the basis of that, they will give you the expression and they will ask you whether it is a polynomial or not. So the reason is very clear. If all variables have exponent as whole numbers, then it is a polynomial. If it is not, like if exponents are in fraction or they are negative or they are in root, then the given expression cannot be a polynomial. Now come to this, the types of polynomials. Polynomials are actually defined in two ways. First, on the basis of number of terms, which you have done in class 9th. Monomial means there is only one term. Binomial means there are two terms. Trinomial means there are three terms. And if there are more than three terms, we can simply say a polynomial with 4 terms, polynomial with 5 terms, etc. So now we are only classifying this on the basis of exponent of x, highest exponent of x, or types of polynomial you can say on the basis of degree. Degree means the highest power that variable has in an expression. So first I have written the constant polynomial. Constant polynomial, we can general form is px equal to c, where c is not equals to 0, means some constant. For example, px equal to 2. So in that case, the degree of px will be how much degree? 0. degree, yes, because you can write, reason being that px can be written as 2x is to power 0. So highest power of the variable is 0. So degree of px, we can say it is a 0. Now come to the linear polynomial. Linear polynomial means px, general form I am talking about. This is ax plus b, where a not equals to 0. I think last year also we discussed this thing in class 9th, that a cannot be 0. If a is 0, then this term will got cancelled and ultimately only b will be left. So b will be a constant polynomial. So a cannot be 0 in any of the case if it is a linear polynomial. Example के लिए you can see this example, px equal to 2x plus 3. So here the exponent of x is 1. So the degree of this polynomial is 1. So all linear polynomials means we are talking about degree 1. Okay, come to this now. Quadratic polynomial. Quadratic polynomial means degree 2. You see px ax square plus bx plus c a not equals to 0. So this is again a cannot be 0 in any of the example. Here you can see some examples, 2x square plus 3x plus 2, x square plus 2, x square plus 2x, x square, etc. They all are the examples of quadratic polynomial. You have to see that x square term has to be there, whether other terms are there or not. Cubic polynomial. Cubic means when degree is 3, means the highest power of the variable is 3. So general form is ax cube plus bx square plus cx plus d a not equals to 0. For example, 3x square plus 2x square minus x plus 2 comma 2x cube 3x cube plus x square comma x cube, etc. These are the examples of cubic polynomial. Now come to biquadratic polynomial. Biquadratic polynomial means degree 4. Px is equal to ax4 bx cube cx square dx plus e and a not equals to 0. So this example I have taken a, you can see example as 3x4 plus 8x cube plus 5x square minus x plus 1 x comma x4 plus x cube 4x is to power 4, etc. These are the examples of biquadratic polynomial. Then zero polynomial, though I was thinking not to discuss this, but it is okay now to discuss because you must have done this all. So zero polynomial means if px equal to 0, it is a 0, it is not constant. So this is called the polynomial, zero polynomial. And I would like to ask from you all, then what is the degree of this zero polynomial? This is very important question of 1 mark. So degree of px in this case is, we can say it is not defined. Some of you might be thinking why it is not defined, something like this. So I can explain you in little, like that px equal to 0 can be written as 0 into x1, or can be written as 0 into x square or 0x cube and so on. So there is no perfect number which can be obtain the position of a degree. So simply here the degree is not defined. This is very important question. Please keep in mind the degree of zero polynomial is not defined. Further to the meaning of zero means what is zero of a polynomial. So rather than giving you the definition in the beginning, I would like to give you the example. Let px equal to x minus 3. So you can see if I put x equal to 3 in this polynomial, then what happens? P3 will be 3 minus 3 equals to 0. So now you observe that at x equal to 3, the value of the polynomial becomes 0. It means that x equal to 3 is the 0 of the polynomial. So remember this simple definition, that any value of variable, not x always, any value of the variable used in the polynomial which makes the polynomial 0 is called the 0 of the polynomial. Now come to the geometric meaning of zeros of polynomial. This geometric meaning is important to understand. I've highlighted this with the black marker. Why it is important? Because you should know how the graphical meaning is is there in terms of 0 of the polynomial. Let's say px equal to 2x plus 3. You can see this is a linear polynomial. So if I ask you ki how many value of x can be there which can make this value as px value as 0, so you can simply say there can be only one value. So let's how to plot the graph. You know that we take some value x equal to -2, then y means this px will be -1. If I put x equal to 2, then 2 into 2 4 plus 3, this is 7. If I plot the graph, so this is px, I'm taking as y. So after plotting the graph, you are getting the graph like this. So you see that this graph is cutting x axis at this point. This point is -3/2 comma 0. So here the value of y is 0 when x equal to -3/2. It simply means that -3/2 is the 0 of this linear polynomial. So again you see, if x equal to -3/2 is 0, it means that it is cutting the x-axis, and at this point, meeting point of x-axis and this line, this y value of y is 0. Now come to the next. Let px equal to x square minus 3x minus 4. This is a quadratic polynomial. I want to plot the graph of this. So I have taken several values. Like if I taken x equal to -2, then put here this is -2 whole square, this is 4, then -3 into -2, it will become 6, and this -4, so it becomes 6. If I put x equal to -1, then 1, this plus 3 4, and this becomes 0. And if I put 0, then it becomes -4. If I put 1, then it becomes -6. If I put 2, it becomes -6. If I put x equal to 3, then it becomes -4 4 0 5 6. So you yourself can calculate the values at x equal to this. Okay, come to now. I have plotted the graph. Graph means this is 6 comma 1, this is 6 comma -2, -6 comma 1, this is -6 comma 2, this is 4 comma 0, this is some point which is cutting here. This is your -1, so this is x -1 and y 0. And after joining all these points, you are getting the graph like this, and this is actually called the parabolic graph. Remember this word parabolic. Shape bhi bol sakte hain, you can say parabolic shape or parabolic graph. So whenever you get a quadratic equation, you will always get a graph like this, parabolic graph. Now few important things are there. Tell me at how many point this graph is cutting x-axis. So you can say at x equal to -1 and at x equal to 4, this graph is cutting x-axis. So it means that this graph has x equal to -1 and x equal to 4 as zeros. So again I'm telling you in simple words, any graph, if it cuts at x-axis, so that point on x-axis will be called the 0 of the given polynomial. Here x equal to -1 and x equal to 4 are the zeros of this polynomial px. Now here one important thing comes. See here, this polynomial is x square minus 3x minus 4. At place of a, you can see if nothing is written, 1 is always there. So a equal to 1. And remember this, if a is some positive value, then graph means this parabolic shape will be open from the top. And if a negative means a less than 0, then this shape will be coming down and it will be opening downwards. So this is very important thing that you should keep in mind, and it comes always for 1 mark most of the time. Now after having the discussion on the graphical representation of 0, now we will take the exercise 2.1, and in the first question, which is based on graphs only, this question is asking you in the following figures how many zeros are there of the given polynomial or graph, you can say. So you first see that this is the graph, this is the line, you can see. Now is this line cutting x-axis at any point? No. So it means that this polynomial has no zero, or you can say there is 0 of the polynomial. Now come to this. This is a graph of this px, and this is cutting x-axis at this point. Let's say this point is a. So it is cutting only at one point. So it has 1, 0. And you should not bother about whether the px is quadratic, biquadratic, cubic, whatever it is. We are not asking this, and you should not bother about this. You should just keep in mind at how many points that px is cutting x-axis. So this x-axis is there is only 1 point, so 1, there is only 1, 0. Now come to this figure number 3. This is the first point A where this graph is cutting. This is the second point B. This is the third point C. So there are 3 zeros of the polynomial. Now see this. This is A, this is B. So this graph is cutting x-axis at these 2 points. It means it has 2 zeros. So come to question figure number 5. You see this is A, this point is B, this point is C, this point is D. So this graph is cutting x-axis at 4 points. It means it has 4 zeros. So these questions are important, and they can be asked in 1 mark. The graph has how many number of zeros. Now you see this is point, last part A, this is B, this is C. So there are 3 zeros of the polynomial. Now we'll move forward. We just want to give you the relationship between zeros and coefficients of the variable. When we say the coefficient of the variable, it means a, small b, small c. They are the coefficient of this polynomial. And let's say alpha, this is alpha, and this is beta, are the zeros of px. It means कि if you put x equal to alpha, then this polynomial will become 0 because alpha is a 0. And if you put beta at x place of x, then this polynomial will become 0. It means that beta is the 0 of the polynomial. Now the relationship is this, that sum of the zeros, whatever the number, the values of x which makes the polynomial 0, there will be maximum two possibilities, because this is a quadratic one. So maximum number of solutions can be 2, but there is no minimum. Minimum can be no solution, means no 0, but maximum is only 2. So sum of the zeros will always be, you can say sum of the zeros as alpha plus beta. This will always be equal to minus b by a, and product of zeros means alpha into beta equal to c by a. So this is the relation between coefficient and the zeros of the polynomial. We'll be doing questions on the basis of this in next exercise.